Welcome to ClickMyProject.com. Our project title is the Accelerating Crop Yield Multi-Sensor Data Fusion and Machine Learning for the Agriculture Text Classification. This is our abstract. Farmers and agronomists now employ sensors to aid with the operational improvement to remotely monitor their crops. They use sensor data sent over IoT. In the name of the modern farming, farmers today manipulate the environment in which their crops are grown to maximize the yields. The harshness of the weather and the changes in disease on the other hand have an impact on the crop productivity. This paper's main goal is to introduce the Multisensor Machine-Learning Approach, a revolutionary method for the classifying multi-sensor data. Fusion technique support high-quality data analysis for cultivation suggestions in agriculture environment. 8 crops were classified based on the suggestion recommendation system. Two machine learning methods were used to categorize the different types of crops, decision tree and KNN for finding the suitable crop for the season. In this project, take temperature and humidity as a feature for finding the crop which is suitable for the climate, and also calculate the accuracy classification report and also calculate the confusion matrix for the prediction of the crop. This is our objectives. Design a crop prediction website coordination with the climate changes. Utilize the ML algorithm for the more accuracy. Enhance our project to the website framework for the user experience. This is our flow diagram. We take the crop data set as the input data. Then second step is the pre-processing, handling missing values and the label encoding for treating the string values, and then move on to the next module is feature extraction. Here we take 3 features: temperature, humidity and pH. From 3 features we want to classify the crop according to the features, and then in classification format we use the decision tree and KNN, and then dump the model and loading the model, and then as a pickle format, and then finally predict the performance of the our usage models like accuracy, confusion matrix and classification report. Prediction, here prediction is in the type of which crop type is suitable. This is a system architecture. From the data set, first next step is the pre-processed, and then split the data as the train and test, and then extract the features. Classification format, we implement the ML algorithms KNN and DT, and then prediction. Here prediction is in the form of crop type, performance analysis, accuracy, confusion matrix and classification report. And this is a block diagram. From the data set, move on to the crop data set. First one is the data selection. Pre-process it and split the data, extract the features, classification using DT and KNN, and prediction. Final one is the performance analysis. And this is a use case diagram. From the user point of view, we want to select the data and pre-process it and split it, and feature extraction, classification, performance analysis. Here diagram, first one is the loading, pre-processing, splitting as the train and test, extract the features of the temperature and the pH and the humidity, classification using ML algorithms, DT and KNN, performance analysis, parameters like accuracy, confusion matrix, classification report. Sequence diagram, 4 sequences. First one is the loading, pre-processing and classification, performance analysis. In loading, we want to select the particular data. Pre-processing, label encoding and the handling missing data. Classification, applying the ML algorithms. Performance analysis, or performance analysis of the ML algorithms. After executing our main code, we have the crop prediction website like this. First is the crop data. We have to select the first 10 data. Here we here is the number of crops we used at what percentage of the temperature, humidity it will grow. And the next one is the humidity and pH and temperature likewise data. And next one is the pH and rainfall data. This is our crop prediction. By using the decision tree, we have to enter the sum input. This is a kidney beans, and then this is a KNN. Same KNN, we have to predict the same values. This is the same. This is about our project. This is a millet, and this is decision tree.